Welcome to another tutorial of Proflan YouTube channel. In this particular video, we're going to discuss the main concept that you must understand as far as Igcse sequence and series is concerned. "26 terms." So in that case, what you need to understand is that for you to find the solution of this question, nth term for an arithmetic series, nth term is given by the formula a plus n minus 1 into d. Now, in this case, a is the first term, and our first term in the sequence is 2 plus n. We are finding the 25th term, so n is 25 minus 1, and d in this case is the common difference, and the common difference is the difference between each of the two consecutive terms. This is 4 minus 2, which is going to give us 2, or 6 minus 4, which is going to give us 2. So the common difference is 2. So if we work out this, you are going to get your answer as 2 plus 24 times 2, and finally this is going to translate to 48 plus 2, which translate to 50. So the 25th term of this sequence is 50. Then for the second part B, we are supposed to find the sum of the first 26 terms. The sum of the first 26 terms, first we need to write the sum number of terms, the sum of n number of terms in an arithmetic sequence is given by the formula Sn is equals to n over 2 plus into bracket 2a plus n minus 1 into d. That's the formula we're going to apply. Now, in this case, we're going to say that this is going to be 26 terms. So n is equals to 26, and that is going to be 26 over 2 into brackets. The first term was 2. Yeah, the first term now in this case is 2. 2 times 2 times a, and a is 2, so that becomes 4 plus n minus 1, that is 26 minus 1, and the common difference in this case still is 2. So this will be 13 into brackets 4, and this 25 times 2, 25 times 2, this is going to give us plus 50. So that is about sum. You need also to understand how to use the formula sum of n terms is equals to n over 2 into a plus l. Yeah, and this one where a is the first term, l is the last term, and n is the number of terms. Number of terms. So you need to understand how you can be able to use this formula. The second type of series you need to understand is the geometric series. Under geometric series, the formulas that you are going to meet there are the nth term for that case. Nth term, for instance, if you're having 3, you are having 9, you are having 27, you are having 81. This is a GP. This is a GP. Because you can see you don't have the common difference as the other case that we were having here. So you can be able to get the common ratio, and the common ratio is 9 over 3, which is the same as 27 over 9, and you can see that is what? 3. The common ratio is 3. Now, when you are finding nth term, nth term for a GP, it's actually equals to, nth term is equals to a r n minus 1. Now, in this case, our a is the first term, our r is the common ratio, and the n is the number of the term. So now, for instance, in this question, if you are told find the seventh term, if you are asked to find the seventh term, what you're going to do, you are going to use this nth term formula, and the nth term formula dictates that term number 7 is going to be a. Our a is the first term, which is our a here, so 3, and the common difference, we got it to be 3 at that point, so it will be 3. N is 7 minus 1, so this is going to be 3 times 3 raised to power 6. If you work it out, 3 times 3 raised to power 6, you are going to get your answer as 2187. 2187. So if you are finding the sum of n terms, for instance, be sum of n terms, sum of terms, the formula that you are going to use in that case is sum of n terms is a into r raised to power n minus 1 over r minus 1. That is the case where r is a number greater than 1. And in that case, if a number is greater than 1, you are going to use this formula. And the second formula for Sn is going to be a into 1 minus r. Let me just seek more space. I'll seek for more space at this particular point here. So this is going to be sum of n terms is equals to a into 1 minus r raised to power n and 1 minus r. So this formula will be used if your r is less than 1. If your r is less than 1. Now, for instance, if you get a fraction, you are going to make use of this formula that we are having at this point. Now, there's something that is also known as sum to infinity. Sum to infinity is another area that you must know. Sum to infinity. Sum to infinity. And sum to infinity will only work if your sequence is converging. If your sequence is converging to a small point. Now, for instance, if you have 40 and this becomes 10 and this becomes 2.5, you see now this series is reducing to a given value, becoming smaller and smaller. Then sum to infinity is given by, sum to infinity formula is given by a over 1 minus r, whereby a is the first term, r is the common ratio, and this formula will only work if r is less than 1. That's when it will work. Modulus of r less than 1. So modulus of r less than 1 means r is less than 1 or greater than -1. That's what this value that we have here means. So your r is between -1 and 1. That's when this function converges. So if you have a geometric series which is reducing in that rate, you can be able to find the sum to infinity using this formula that we are having at this given point. Now, I need you to let us just try to work out sum to infinity for this case here. We are going to say our r in this case is going to be 10 over 40, which is going to be 1 over 4. So we can see the common ratio is less than 1. So sum to infinity is going to exist. So this one, we cannot be able to find sum to infinity because you can see the common ratio is 3, which is greater than which is greater than 1. So sum to infinity for this one is going to be, what is the first term here? The first term is 40. So we are going to say 40 divided by 1 minus r, and our r is 1 over 4. So if we work it out, we are going to get 40 over 3 over 4 in that case, and this is going to translate to 160 over 3 as the sum to infinity, as the sum to infinity. So, well, this is the areas that you ought to understand as far as Igcse further pure math sequence and is concerned. Let me just introduce the last case you are going to be seeing in your exam. So we are going to also talk of this particular sequence whereby you are told find we are told find summation of, we are having here r is equals to 1 all the way to 10, where you have 5 raised to power r, and let me just make it a little bit complicated. Let me add 6 here times 2 raised to power r. Now that is beautiful. That's beautiful. So close the door. Then now this expression that we have here, to work out the summation of this, we are going to say this expression that we have here, let me just write it. Summation of r from r all the way to 10 of 6 times 2 raised to power r. You see, the number that is going to be affected, the number that is going to be affected by this r is only 2. 2 is the only number that is going to be affected here by this. So meaning that we can be able to, we have all the right reserved for us to say this can be written as 6 times summation of r from 1 all the way to 10 for r raised to power, no. This is going to be 2 raised to power r. We can be able to write it like that because this 6 is not affected by the value of r that we have at this given point. So we can now say this can be written as 6 times into bracket. Now this r equals to 1 all the way to 10. What does it mean? Let us interpret that summation. It means 2 raised to power 1. When r is 1, this becomes 2 power 1, then plus. When r is 2, we can say 2 raised to power 2. When r is 3, we're going to say 2 raised to power 3. When r is what? Next number here? 4. When r is 4, we're going to say 2 raised to power 4. So plus, this series will continue like that until you reach 2, let me just say dot here, plus. Let me see whether we have enough space. We have enough space. 2 raised to power 10. 2 raised to power 10. Let me adjust this so that you can be able to see. Yes. 2 raised to power 10. Now that is going to be our last term, because 10, we are starting from r equals to 1 all the way r equals to 10. So when r is 1, this becomes 2 raised to power 1. When r is 2, 2 raised to power 2. When r is 3, 2 raised to power 3. When r is 4, 2 raised to power 4. When r is 5, 2 raised to power 5. When r is 6, 2 raised to power 6. It will continue like that until 2 raised to power what? 10. Now, whatever we are having at this point is a geometric progression. So we can be able to see that the first term here is 2, the second term is 4, the third term is 8. So is an increasing geometric progression. So meaning the value of A for this GP is A is 2, and R is going to be 2 raised to power 2 over 2, which is going to be 2. You can even say 2 raised to power 3 over 2 raised to power 2, which is going to be 2 as well. So we can now say our expression here can be what? Sum of up to 10. So this is going to be 6 times 2a, using the formula that we learned, the formula that we stated. Let's see. Sum of n terms. Sum of n terms. Yeah. Sum of n terms. This one here. Yeah. So we are going to say this is going to be, first term is 2 into bracket, common ratio is this one, 2 raised to power 10, because we are going to do it the sum up to 10 terms, then minus 1 into bracket r, which is 2 minus 1. So this is going to translate to 6. 6 times 2, that's going to be 12. So 12 into brackets 2 raised to power 10 minus 1 over 1. So which will mean that if we can put this in a calculator, what can we get? Let's put this into the calculator. Yeah, some of you guys, you are complaining that I'm putting my microphone here. This is exactly what I'm having for now. So I'll get a different mic, because some of you are not happy the microphone being here. Yeah, so this is going to be 12. This is how we're going to write it, and ensure you are instructing your calculator properly for it to give you that. So this is going to be 12 into bracket, the way I'm just writing this, it will be 2 raised to power 10 minus 1, close the bracket, the way I've just put. Are you seeing that? Like that. Are you seeing that? Yes, that way. Then down over 1. Down here over 1. So ensure you put the information in the calculator properly, so that it can be able to give you the correct answer. So my answer becomes 12,276. 12,000. The answer is 12,276 as the summation to that. So this is all about all that you ought to know as far as Igcse further pure math sequence and series is involved. So the rest of the question that we're going to do is whether you can now be able to apply this knowledge. You can be able to apply it so that you can be able to solve examination questions. So if you got that this is helpful, consider subscribing, so that anytime I'm going to upload further tutorials like this one, you'll be notified. See you in the next video.